Well, hello everyone. Welcome to part 8 in my coding of DLL injection into all processes. And today we are going back to my previous function where I started creation of a section and also started adding it to KnownDlls. Just to recap real quick, let's run Visual Studio. And if you remember, our solution was called InjectAll. So let's wait for it to load. And basically we are inside of my CreateKnownDll section. So what we did here, well, first of all, we need to switch this. So I apologize, I was still on the old settings. I prefer to write everything as debug and x64. Because again, it's just a little bit more complex code. So anyway, so we left off on actually defining which KnownDll to use and also defining the name for our own KnownDll that we're adding here. Then we opened existing KnownDll. In this case, we chose kernel 32DLL as our victim here. And what we did here, we actually got a security descriptor from it, which we will use later. So we did memory allocation for it here, and we left off at this point where we were actually needing to have a DLL. So we created our own FAKE.DLL here, which we can compile and build. This is a special type of DLL that basically doesn't use C runtime, so it's very primitive and it relies only on NTDLL. Imports from NTDLL. Okay, now just to show you what KnownDlls are, if we go back to our to our testing environment and run WinObj and switch to KnownDlls, it lets me sort them like this. Well, all of these would be KnownDlls, which is basically DLLs in System 32. Not all of them, but Microsoft for some reason singled out these. And the way loader loads DLL is that it compares them if DLL actually exists in the directory of KnownDlls. This is the kernel system directory. And if it does, it doesn't do any of the checks or any of other search, and it just takes the section from here and pretty much maps it as is. So in our case, if we add our own section to this list, and by the way, there are two of them, for 32-bit and for 64-bit. So if we add our own section to this list, we will be able to bypass all the security checks done by Windows and also load our own DLL or section into required processes. So that's kind of like a quick recap of the theory. So let's go back into our file here, into our project. And at this point, we can begin doing some coding. So we have our DLL, so now we need to open it as file. Let's just write it, open existing DLL that we will be injecting. Now we're using ZwOpenFile, and it will give us, well, a file handle, so let's return it. Now the file, the access mask would be, let's see, file generic read. We just have to read from the file, and also file execute, because that is an executable section. Okay, so then we need to provide our object attributes, and let's just say it will be path to fake, no, not file, FAKE.DLL, in other words, where our FAKE.DLL is located. Now then we need, let's see, well, IntelliSense just died. Oh, here we go. Then we need, let's see, IO status block. Just, we're not going to be using it. It's just like a dummy structure here for us now. Now we need file share read. And let's see, options would be file synchronous. Let's see, no IO alert. And that will conclude it. So, okay, now we need to define our file handle and IO status block, which obviously needed for this function, and it will return us a status code, and then we need to check. Obviously, remember about errors. I always try to leave a block here so that I don't forget to handle an error. Let's see, NT_success to check status. And in this case, if we have an error, we basically can't continue, because pretty much at this point we are done if we can't read our section. So let's reuse our error handling debug print, and we'll adjust it. So in this case, we want to say that here is the function that failed, and we have a PID, we have a section, and we also need to specify the path, and the path would be a Unicode string, and the path will come from here, and that would be an object name. Okay, so we don't have this defined yet, but at least, you know, we can handle errors. And what we also need to do, we need to close our file, and we do with ZwClose, and specify our file handle. And I would also use my verify debugger check macro, and it will verify that we actually got success from closing the file. Okay, so now we need to define this Unicode string for the path to our FAKE.DLL. Now, because this path would be actually different depending on the type of the section that we have here, whether it's a native section or if it's a WoW section, I'm sorry, vice versa, WoW would be here. So we need to define, and that's again, I'm sorry, it's not a Unicode string, it's a constant object attributes, and we can get it from a static value here. Okay, so we can reuse it here. Now for our native code, let's just say that, well, the name would be object attributes path FAKE.DLL, and we add it here, and we do the same thing here. Okay, so we need to provide the name or the path for the native DLL. As always, I will be storing those in my driver types. Now let's see, where did I define where did I define it? Well, I haven't defined it anywhere. So let me see. So I have that. Let's define it after here. And well, let's just say, let's just put a comment that this will be a path where FAKE.DLL is located on disk. And we need to make a little assumption here that to make this injection work, the DLL must be placed in the appropriate system 32 folder, which means that it depends on which type of DLL it is. So, and let's just define a preprocessor constant. Let's see, NT path. Now it has to be special NT path, and let's say NTV for native. And what the special path would be system root. This basically means system32 folder. I'm sorry, that means Windows folder. Then we need system32. And then we need our injected file name, which will depend on the bitness of our build. Okay, and then we put native and do the same thing here, except this will be for the WoW. And for the WoW, we have let's see, sys WoW64. They changed it a little bit. And in this case, we use only 32-bit file name. And we specify in the comment that this is WoW64 on a, as just the WoW on a 64-bit OS. Okay, so now we can actually use these two preprocessor constants inside of our definition here. So let's remove this. Okay, first of all, for the native code, we are going to use this definition. And for the WoW, we would use this path. Okay, so we have system root, system32, and then injected DLL name, which will be, which will depend on the bitness, 64 or 32. And here for the WoW, it will be system root, syswow64, and then 32-bit name only. Okay, so this way we get our path here. And let's see, it doesn't like it because we need, let's see, what is it saying? We need to do a cast here. Let's just do constant cast. And we are casting to P object attributes. So this will open our existing file. It's just basically, it doesn't do anything. It just simply loads our DLL from the path that we specified. And again, the path, which is important for the KnownDll, for our DLL to be actually in the system32 folder. So we'll have to place it there. And then we need to open its PE file as data. Well, let's just say as section. So we use ZwCreateSection, and let's see, well, it will return a handle to our section. In this case, let's just give it a name, which we'll call FAKE.DLL. We'll keep it in a local variable for now. Let's just create it right here so that we don't have the squiggly lines. Okay, so we'll keep it as a variable for now, local variable. Now, as a desired access, we need to specify that this will be section map execute, and we also need section query because we'll query it later. Okay, so then we need to provide an reference to our object attributes for FAKE.DLL, which we had already, which we created above. Now we don't have this parameter. Then we need to provide protection flags, which is page execute. We have to map it as image. For some reason that didn't find. And we are taking it from a file. It will return us status. And as always, we need to check for success. and process errors. So let's use our usual processing debug print. Okay, so what we have is that we have a different API. And by the way, we don't really need this. And just the leftover from previous copy and paste. Okay, so we have an API. We have a process ID. We have section type. And we have path. Well, we don't need path here because we are done with the path since the file has been opened already. And what we also need to do, we need to close our section. We need to remember to do that. And I'm just going to reuse this line. And I need to put FAKE.DLL here. So at this point, we can open our PE file as section. And for some reason, the WDK doesn't define sec image. So I'll have to define it myself. So let me look it up. So let's go to driver types, and I'll just scroll, I don't know, all the way down here and just say if not defined, and if, and then we say define sec image, and I'm going to copy and paste because I don't want to make mistake in the number of zeros here. So, and that will define our constant here. Let's try to build it to make sure that it builds, and it does. Okay, so at this point we have a handle to our fake section, and the name for it actually comes from this object attributes for FAKE.DLL, which we filled in here. I'm sorry, not here, but here. It also specifies it as permanent, and it also provides a security descriptor for us over here that we took from KnownDlls. And the name actually comes from here, which is this. If you remember, we did this in a previous module. So, okay, well, at this point, we have our section right here if we succeeded. Okay, well, we will technically have to do more work here. Let me put a comment and say more work needed here. And the work would actually involve getting some information about the section, but we don't really need it for now. And what we need, we actually have to fill out our stats variable. So what we need is to put section type into it and put the section object itself. So let's do that. Now if we scroll back to it, we can get the section object from calling an internal API that will convert our section handle into section object. And this is called ObReferenceObjectByHandle, and we'll be good citizens and use the tag. It's a long function, so let's just use IntelliSense, I guess. So first it takes the handle, which is our fake section. Now we're not going to specify desired access, we'll just use default, and object type will be also default. What's important is this is a kernel mode, so that, you know, this is a safety thing. We will ensure that, you know, the reason, you know, basically this kernel mode flag is so that we will protect it in case this object leaks into user mode. It won't be usable. Okay, we need tag. And the tag would be, let's say, HF, I don't know, KS, just like something unique. Okay, so then we actually need the object itself, and that will be this. And the last parameter, we don't need that, will be null. Okay, obviously it returns status, so we'll need to check for NT success. and do exact same thing if it fails to deal with the failure. And over here, let's put a comment that we are getting our section object pointer, and then increment its reference count. Now the reference count is done internally inside this function, and the reason being is that it tries to keep the reference count up by 1 so that this object is not deleted. Additionally, if you remember, our section here will be a permanent object, which we set up over here. It means that if somebody calls ZwClose on it, it will not be removed, which is important for us because obviously this section will be used throughout the life of this module, of this driver. I forgot what I'm writing. So okay, now we have this. Now what we also need to do, we need to deal with errors. This is obviously very important. And what I will do, I will simply reuse this call here. Now the important thing with copy and pasting like this is to make sure that I actually change everything the right way. So we specify an API. I'll just remove with tag just to make it a little bit shorter. And we have PID and we have section type and status originally, so that should work. And if we get here, we can say that we're done and set return parameters. And let's just specify status as status success. And the reason I'm doing success is because, here we're checking for warnings too. So in case there's some kind of warning, we need to make sure that we return success here. And again, I don't know exactly why it would return something other than success, but if it does, we have to clear it to the actual success here. And what we need to do at this stage is to set our section type, which would be section type from our class. If you remember, our class also has section type, and that's what we will pass here into our object. And again, the object we're filling in is DLL stats, and that's how we'll make it valid. So, and again, the section will be filled out here. So at this point, we will have our object ready. Well, just as a debugging help, let's just do our debugging verbose. Let's see. I forgot already what it's called. Verbose driver. And over here we can say debug print line. Oh, come on, print line IntelliSense. And we can say KnownDLL. Let's see, created. And then we can do process ID. And section, you know what, I can just take it from here. Section type, process ID, and section type. So it will just output that information for us. There's no status, obviously, because we just succeeded. And this output would go only if we have a verbose driver build. And this little line will tell us for which process we just created our KnownDLL section. If you remember, we're calling this from a singleton, so it will be done once per bitness of our section. So, okay, well, that part is technically done. So, since we created this object here, we need to take care of it and make sure that we actually close it, and we do this when we do our FreeSection. So if you remember here, we had this DLL stats that we were receiving from the context, and we had a little debugging message here, and then we can actually remove our section, which is stored as a reference in this DLL stats structure. But before we do this, we need to remove permanent flag from the section object. If you remember, we created it as permanent, and the way you can do that is by using ObMakeTemporaryObject function. So, and what we need to do is to pass a section object into it and dereference it. And the way we do this is with this API DereferenceObjectWithTag. Again, we're going to be a good citizen and use the tag. And again, we provide section here and provide our tag. And just to get the tag itself, if we go into CreateKnownDll, let's see, where was our tag? That's not it. There's a lot of code in here, so let's make sure. Yep, here you go. This is the tag. And we go back to free and put the tag. So at this point, when we dereference our section, it will no longer be valid. So we can just null out its object pointer to make sure that we don't refer to it anymore. This is important to prevent use after free. And this is how we should be able to remove our section. So let's make sure that the code builds, and it does. So at this point, we created our section, and we can go on with our further injection. You know, there is one thing that needs to be done here. I just realized when we made this temporary object here out of our section. Now, if we go back into CreateKnownDll, and if you look closely here, now here in object attributes, we create our section as permanent. Let's make sure that we deal with errors correctly. So right here we have our fake section. So if we succeeded, so we close our section handle, which is fine, and we can do that because we did, you know, object reference here, so it won't be closed. But because our object itself is created as permanent, if we fail, for instance, if this function fails, or if we fail somewhere else in the process, we need to actually remove that permanent permanent status for our fake section. So let's just do this. Did we fail setting this section up? And the way we can tell that is if NT success is false on the status, and then we need to make it not permanent so that we can remove it. In other words, if we did not succeed, we need to call this ZwMakeTemporaryObject, and we need to specify our section handle. This is the function that takes a handle, and we will put our verify macro here, and also we need to provide NT success to do it like so. So what will happen in this case, now if for some reason our additional work did not succeed, we need to close this fake section, because we did not create an object out of it, and we did not need it. So in this case, to delete it, to remove it, I'm sorry, with the ZW close, we need to make sure that this is a temporary object, which we set up earlier. So we need this little thing here. Okay, so at this point, let's try building it again, and we can actually try testing it in our testing VM. So it builds all right. Let's also build a FAKE.DLL as 64-bit release, and also FAKE.DLL as 86, also release. Okay, so both built all right. So let me return configuration back into x64 debug. That's how I will be building my section. Okay, so let's look at the location where we just built all this stuff. Well, first of all, let's deal with the DLL. So x64 release and FAKE64 DLL. Let's make sure that it doesn't have any unnecessary imports. And it doesn't, it just import from a nt.dll, which is nice. So let's copy it and then switch into our development machine. Okay, so we need to go to, oops, not here, system. My goodness, this is so annoying. Okay, local C, Windows, system 32, and let's copy it here and then move it here. Okay, so we put our FAKE.DLL into system 32, and we also need to do for 32-bit DLL. So let's go back, and we need to go to release FAKE32. Let's make sure that it doesn't have any unnecessary imports, and it doesn't. All we have is just nt.dll. Let's copy it, go into our test environment. I'm copying it to desktop first, because sometimes virtual machines don't really do well when you do this kind of like copy between them. Okay, so we have 32-bit DLL here, so now we need our driver. Now in this case, we are going to use a debug build, and this is for x64 debug, and we have driver64.sys. Let's copy it and paste it here. It's a little bit larger file already. Okay, so now what we need to do, we need to clear our debug view, and then we need to register and start the driver, and it started okay. Now if you remember, it waits for Notepad only, so if we run something else, like a calculator, it doesn't do anything. But when we start Notepad, it should create our section. And here you go, KnownDLL created. Now if we run it again, it should not create the section. As you can see, it created only once, which is a singleton. Now the interesting thing, let's see if we actually, if we can find this KnownDLL. If we go into WinObj, KnownDlls, sort, and let's take a look. Well, here you go. We have our FAKE64 DLL as a known section, is a native one, and obviously it's not yet in a KnownDLL 32. So let's try to create not create, but run a 32-bit version of Notepad, and we'll see if the section will be created there. So let's see, syswow 64. Let me find Notepad and run it. Okay, and we got an error. So in this case, let's see what happened. So we have, let's see what I usually do. I'm using WinAPI search, and I'm searching by this error code. So if we go into view error code search. Let me just kind of like scoot the window over here this way. And if we search by 0xC0000035, and let's see if we find anything. Okay, so NTDLL object name already exists. Well, let's see why we failed. So we need to basically let's see, did we, okay, fake64, okay, so what we have is a failure in ZwCreateSection. Let's unregister our driver so it doesn't mess up, because there's some kind of issue obviously. And let's go back to our coding environment here, and let's see, CreateSection, this API, and we are getting an error that it already exists. So let's take a quick look. So it's not here yet, and we get it from here, and this was the actual name of the object, and we're getting it from this FAKE.DLL, which is a fake32, right? KnownDlls fake32, and this one is also KnownDlls. Okay, that's interesting. Okay guys, I apologize. I had to stop this recording, and yeah, so if we get back, so if you remember what we were doing, we were trying to test our driver, and we were getting this error, which is C blah 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 035, and if you look into error code, it says object name already exists, which was kind of weird, since we were creating you know, the one section was, you know, the 64-bit section created okay, but then the 32-bit for some reason didn't. And then I started looking into it. Again, I was distracted, so I literally have to record it the next day. So basically, if you look at the section type, it's also 0, and the section type here is 0. So that seems to be a little bit of a problem, because section type should be different. So if we go back to our code, and if you look at our class, we have this Initialize method that should set the section type. And again, the problem here is that we can't use a constructor for our class to actually initialize it, because again, it's a global class, and you know, the constructor would not work for the driver here. So we have to remember to call our Initialize method, but if we search, well, it's not called anywhere. So this is a problem. Now, and it also seems like when our object is initially declared in memory, it's set to 0, which seems to coincide with this native type. So what I suggest we do is that we set some kind of arbitrary values for the type, meaning that, you know, if we fail to initialize our class here, then getSection will actually fail here, and it will give us an assertion. So let's see what happens. So if we rebuild our driver the way it is without calling Initialize, and then if we go into InjectAll and go into 64-bit folder and take our driver and then copy it into our test environment. By the way, I have too many windows open here. Let me move this out of the way. Okay, and then I need to actually clear here and register and start the driver. Okay, well, let's try to run Notepad. Well, right off the bat, we get an assertion. Okay, now section was still created, but this little line here basically tells us right here, if you look at, let's see, where's my lines? Come on, Visual Studio, give me my lines. Oh, right here. Let's say line 33. If we go back, it tells me right here, line 33, in CSection CPP, I have an assertion. So this is a very handy way of actually catching these kinds of bugs. Obviously, we would have known it later on, but you know, that's why our section type pretty much doesn't change. So if we go back and basically correct, what we need to do is we need to initialize every section so that we actually tell it the section type. So let's do it right now. And the way we can call it is from our driver entry from the very beginning. So when we set our object here, let's do initialize our section object, and for section, which is native section, we call initialize, and what we do, we provide native, and because technically that should succeed all the time, let's just do verify and nt success as so. Okay, hold on. Well, I guess I need to know how to spell success. Okay, and in here, if we are doing a 64-bit build, we need to initialize our wow 64 section, and in this case what we need to do, we need to initialize it as a wow, and that's pretty much it. Let's take a look. I think that will do. Let's make sure that our section is freed in driver unload. Okay, we call free resources, and in free resources we call FreeSection. Okay, we call one for native and for wow, and let's see FreeSection itself. Again, I'm just kind of reviewing it because, again, like you guys, I'm actually writing it within, you know, after a short break because, you know, like yesterday I had to do something else, so, you know, I'm kind of like losing some of it. Okay, so we have remove our section here and remove memory, and we set our singleton back. Okay, well, technically that should do it. Let's rebuild it. Let's do it right here, rebuild, and let's go into our driver 64-bit. Let's copy it, and in this case we will copy it into our test environment. And let's make sure that this is cleared. Let's register and run. Okay, now let's start Notepad again. It's running. Let's close it. Let's start new instance, and it created OK. And now the real now the section type is kind of weird, so we'll have to change that. And now the real test is actually when we start a 32-bit version of Notepad. So let's see what happens. And we got another assertion. Well, let's see why. And section line 33. So let's take a look. And that's right here, and again it gives us line on this column. Let's see, yep, it's right here, and for some reason our section type is still 0. Interesting. So if we look back, you see it wants to section type is 0. So let me see what am I missing here. It is interesting. It still tells me line 33, but if we go back, it is actually line. Oh, it is line 33, right? Yeah, it is line 33. Okay, so somewhere this section type is not defined for our WoW section. So I'm sure you guys see it, and it's probably very obviously, yeah, I just declared the WoW section. Anyway, guys, that's what happens when you try to rush things. It has to be section WoW, obviously, over here. That's what happens when you do copy and paste, by the way. Very kind of dangerous thing, but we all do it, right? Okay, so rebuild. And another mistake that I always tend to do is that I rebuild something, but then when I go to the folder, I go to some wrong one and basically copy the old DLL, which I didn't change. So that's another mistake I've done like 20 times probably during my testing. Okay, so we need to stop the driver. And stopped. OK. Well, let's see if we can do it this time. Let's clear it. And let's register and start. OK, this one usually starts all right. And again, let's try 32-bit. Yay, what do you know? So it actually did start. And let's check that we have both objects here. And let's sort it. So we have 64-bit FAKE.DLL as our KnownDlls, and we have our fake32 KnownDll also present. And we seem to be, creating them, obviously. So if we run a notepad again, as you can see, it doesn't create them. And if you go into 32-bit version, it shouldn't create the new section either. Okay, so that's really nice. And as you can see, we get, let's see, where's the bitness? It doesn't tell us the bitness. Oh, because it's a driver, we have like WoW. And the only thing we need to do, we need to change the section type to something which is more readable. So let's do it right now. So if we go into our coding environment, we have quite a lot of things like here. And what I would suggest is just changing it to a character. So that will output the name, because if you go into section type, so what we did, we just put basically N for native and W for WoW. And let's just refactor the whole thing and change it into C. The easiest way is just to go like so. And let's say find and replace it as such. Let's say find next. And let's see, I usually don't like replace all, because quite often you can make, some mistakes. Let's just do replace, and it would be actually nice if we can see what we're doing. So replace, that's here, here, here. Yeah, I'm just looking to make sure that this is the correct place where I'm doing that. And there is no more. Let's just check real quick that all of them have been covered. And C basically will output a char or a character for us. Okay, yeah, section type. Okay, well, let's do one more build. You know what? I usually do it right here, rebuild all, to make sure that I rebuild the right project. And we go to driver 64. Let's switch to our testing environment. By the way, let's unregister. Let's make sure that, yep, FAKE.DLL has been removed from the KnownDlls. Let's copy here and clear our debug view and run. So now when we start Notepad, yep, so section type N for native. And then if we do 64-bit, section type for wow. So here you go. So that works. Now at this point, let's stop our driver. And yeah, that's more readable. It just tells us native or wow. Okay, and if you remember, if let's see, I'm trying basically to refresh my own memory. If we look into our test console, we called our set security descriptor on InjectAll folder, and what it did for us, it set all of these basically access rights for that folder. And one last thing I want to do, I want to go back and make sure that we actually did it. So if we go into InjectAll, and then in our test environment, obviously, and if we go into properties for our folder and go into security, now it doesn't really show it all here. If you go into advanced though, it will. And here you go, untrusted mandatory level, which is important. That what would let us have access from all the untrusted processes when we're injecting our DLL into it, so that we can write into this folder, into InjectAll. And yeah, and also restricted packages, all packages, anonymous, and everyone. So that basically also shows you how complicated security descriptors are in Windows. And here you go. So now we should be able to write into this folder. And one last thing I want to say, that this code here for setting this security descriptor is not really necessary for our, for a production code. We are doing this only for our testing, again, so that we can write into this folder, so that we can write our log from the DLL. Let me see, where is our DLL? Okay, so that we can do our debug print line, which calls this function to create a log file inside. Because again, this DLL can be loaded pretty much into any process with very low security descriptor or mandatory, what do they call it, mandatory integrity level. And like for instance, what do they call them, web browsers, they have very restrictive security descriptors set up on them. And since we will be injecting into them as well, we need to make sure that these APIs would actually write our log file. So this is the only reason why we are doing this kind of thing. Okay guys, so I know it's been a long video. I've been all over the place with it. So next time we will continue our DLL injection. I will see you then, and thank you very much for watching.